Hi guys, we are back again. We are going to go ahead and talk about solutions and solubility. We're going to get into some definitions first. So let's take out notebooks. It would be a really great idea to draw some pictures as we're going. And we can take your time. Teacher can pause this video to make sure that you understand and that you've got a couple pictures drawn in your notebooks to help you with understanding all this. So let's go ahead and get started. Okay, so what is a solution? If you think about it, you deal with solutions all the time. We're not talking about math solutions like a math problem, 2 plus 2 is 4. We're not talking about that type of solution. We're talking about a solution dealing in science. So in science, a solution is what we call a homogeneous mixture. And I want you to think carefully about that word homogeneous. So let's say I have a cereal and I put milk with it. Okay, I've mixed two complete, I have my cereal and I put milk with it because that's how I'm going to eat it. That's not going to be homogeneous. Even though we're mixing it together, it is not homogeneous. So homogeneous is where everything has to come together. So I want you to think of another thing. If I were to make a pudding, a dessert pudding, I can use the milk with the pudding powder and I blend it together and it can't go back. It cannot go back to being powder and milk. So that's going to be called homogeneous. It's together pretty much forever. Okay, so that's when I say single phase, that's what I mean. It's one time and it doesn't go back. Okay, so let's look at the next one. That's an image right there. That one, another good example could be sugar in water, just to throw another one there. Okay, these are just what it looks like if you were to put this stuff under a microscope. And this gets into some complicated stuff, but that's all good. If you notice the picture on the left up here, let me find my mouse, the picture on the left, they have put this powder in this liquid. Okay, so that's what the powder looks like under the microscope. And this is just plain water. Now, once it gets in there, you notice that it's been scooped out. Now we put it in, and obviously it's blue now, a blue tint. But this is what it looks like under the microscope now that we have added that blue powder. So you can see that there's a big difference from over here. So that's exactly what we're talking about when it's homogeneous. This is what it looks like before, and then of course this is what it's going to look like after, because it can't go back. Okay, so let's move on to the next one. The next one, this is where we can get into solvents and solutes. So this gets a little weird too. So normally what we do is we have something called the solvent, and then we have something called the solute. And let me get into some definitions here. Let me move my camera out of the way here so you guys can see it. So when we take salt and we mix that into water, it dissolves completely. The salt disappears, but we call that dissolving. So in this case, what we put into the liquid is called the solute, and then the solvent is the liquid that we're using. So again, and just so you know, water is the most popular solvent in the world. Okay, let's move on to the next one. Okay, so we have different parts of a solution. We have the solute, which is the part of the solution that's being dissolved. Then we have the solvent, and that's the part that dissolves the solute. Okay, so a lot of S words in here. So we have solute plus solvent equals a solution. And there's a good example right here. If I want to make hot chocolate, my answer when I'm all done is going to be the hot chocolate. But I use milk, I use cocoa powder, and I mix them together and it becomes a solution of hot chocolate. I hope you're so far so good on this. Okay, so now this is where we get into some weird stuff. This is called soluble, insoluble, or is it miscible, immiscible. So let's go through all these words. Okay, soluble, it's a substance that can be completely dissolved. So if I can dissolve something, if I can just pretty much make it disappear, that is called a soluble. And insoluble is something that just cannot be dissolved. It's not going to go away. It's not going to break up. And a good example of that would be, think about your yogurt carton, or think about a milk container. If I were to put that milk container in a jug of water, is it going to go away? No. That means it's insoluble. But if I get my cocoa powder, or if I get a drink mix and I put that into the water, that disappears. Or if I get salt and put that, it's a substance that can just go away. It can be absorbed, it can be dissolved by the liquid. Okay, so now the next one's called miscible and immiscible. And this gets a little strange too. So let me explain both of these. Miscible is really basically a substance that can be taken in by the other liquid. We're going to call that soluble. So it's going to be a liquid that we can put into another liquid, and it just makes it disappear. Okay, we're going to do an experiment in a second. And then immiscible is a substance that is insoluble in another liquid. Okay, so let me give you an example. I've got something right here, and I'm going to make my screen big for a second so you can see it. So here we go. Okay, you can see right here, it is blue on the bottom and white or clear on the top. I'm not going to tell you what's in this because it'll give it away, and we don't want to do that. So now I'm going to shake this really, really hard. Shaking, 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 shaking. Okay, here we go. The whole thing's blue now. But if you pay attention, I think you can see this on the screen. We're going to keep it really still. See what happens here. Does anybody notice what's happening? If you think you notice what's happening, raise your hand, because I'm sure somebody notices something's changing here. And if you can figure that out, put your hand in the air, let the teacher know that you want to say something, because this is really important. This is really, really cool. Well, look at that. It looks like it is back to the way it was. Let me see if I have something white here I can put behind it. Yes, it looks like it's going back to the way it was because it's clear on top again. And this will not mix. So this is what we call immiscible. And the easiest way to think about this, if you think about the word miscible, like mix, and then immiscible, meaning it can't be done, immixable, not it can't be mixed. So that might be the easy way to remember this. So this is immiscible because it will not stay together. It has to come apart. So let's do this again, just so you think, so I'm not joking around here. It's all blue. You can see that it's all blue, and it's going to come back apart. It's going to separate. So that's what it's doing. Okay, this is immiscible. Okay, we're going to put that aside because you're going to be doing a little experiment shortly. So let me go back to the presentation so we can get to that, and then we'll get started. So what I want you to do, and this, oh, I'm sorry, this is just one more way of looking at it. This is soluble, again, a substance that can be dissolved. Insoluble, can't be dissolved. Miscible, will combine. Immiscible, cannot combine. So there you have it. You can see the difference on this screen here. This cannot stay together, so it is immiscible. This over here is mixed together, blends together, combines together, whichever way you want to say it, and therefore it is miscible. Okay, so let's talk about some solutions. Some solutions, there are what we call gaseous solutions, which mean it's gas, air, you know. Liquid solutions, and let's go back to air for a second. The air that you breathe is it's oxygen. So you think about that. When you breathe out, it's carbon dioxide. So that's a gaseous solution. We have liquid solutions. If you put anything in your water to make it taste better, that would be a liquid solution. And then we have solid solutions, which I have an example here. If you're familiar with if you ever have to go to the dentist and they have to fix your tooth, that is called a solid solution. And that's also known as an alloy. So let me go ahead and move on now. I want you to make some predictions. I want you to open up your notebooks and I need you to make a prediction. And before I have you do that, if you want to look at this really cool picture up here, anybody have any idea what that is, how that happens? And so if you look at that, is that miscible or immiscible? Does it combine and disappear? Or does it separate back out? So think about that for a second. I will tell you that that is diesel fuel, which you would put in a truck. Some of it spilled on the road and then it rained and that's what happened. I just thought it was a real pretty picture, so I thought I'd use it for you. And then, so just think, does it mix or not? So that's your thing to think about. Now, let's talk about making these predictions. What I want you to do is I have a couple items down here on the bottom, and I have oil and vinegar. So think about oil. This is cooking oil, not the oil that you put in a car, but oil like you would put with food, cooking oil or olive oil, whichever oil would be the easiest to get to, and then vinegar. And think about that. When I come do oil and vinegar, is that going to be miscible or immiscible? Think about that for a second. So I want you to write down, because you're making a prediction, you're making a guess what's going to happen. So is it miscible or immiscible? Again, remember, miscible comes together and will not come apart. And then immiscible comes together for a while, ooh, and then separates. So that's immiscible. So then oil and vinegar, and then think about alcohol and water. So we're talking about rubbing alcohol. Rubbing alcohol would be used for different things. Sometimes you would see a doctor's office maybe cleaning off an instrument, or maybe if you have a thermometer that needs to be cleaned or sanitized, a thermometer like the kind that you would use for taking a temperature, that can be wiped down with alcohol. You'll see doctors' offices use rubbing alcohol a lot. So think about this. Alcohol and water, is that miscible or immiscible? Just another thing to think about. So those are your two challenges, and I'm hoping that you're going to do this right there in class, just a short little thing. And if you're not sure what you're going to need, just a small bottle. You can even use one of the water bottles. If you have a water bottle that is just something that you've picked up or brought in for your recycled materials, use a water bottle, and then a little bit of oil, a little bit of vinegar, and it doesn't have to be the whole thing. You can use just a little bit because it doesn't take much to tell you if it's going to be miscible or immiscible. So oil, and then shake it up, cover it up, because you don't want it flying all over the room. Shake it up, watch it for a second, make an observation. What's happening, what's happening, what's happening, and then go from there. And then after you've done that, we're going to do another one, then do alcohol, rubbing alcohol and water. And what happens, again, shake it up, make sure the top's on, shake it up, shake it up, and then does it come apart or does it stay together? So do your predictions, do the test, and then we'll see what happens. So I'm going to leave you with that. Let me find my mouse again and we will move on here. So there you go. I want you to think about this after you test it. Were you correct? Now remember, this is science, so you don't have to be right all the time, because that's the cool thing about science. Science lets you be wrong, so then you can find out the right answer. So I'll check back in with you shortly. Let me know how you did, and I hope you really enjoyed my cool little experiment here, because this is really fun. I'm trying to get it back to big screen for you, because as you can see, it is completely separated again. I'm going to put something white behind it so you can see the difference. I'll shake it again one more time for you. And that's a white label on there, by the way, just so I remember what it is. So let's see if I can do it that way. You can see the difference, and it's kind of changing. I'll see if I can get it closer for you. You see those bubbles? Those bubbles are doing something too. And then it will eventually, you can see it changing at the top, and it just suddenly goes back to the way it was. So I'm not going to tell you what's in this bottle because it'll give away what you're doing. But anyway, have fun with this. I'll check back in with you later, and I hope you're having a good time.